Oh, can you guys hear me? All right, perfect. Okay, so this is going to be our second workshop for today. This is going to be our intro to Git workshop. If you've never worked with Git before, or just need a refresher, this is a great workshop for you. This is our organizer, Jacob Ellerbrock. He's on our tech team and our logistics team, so he'll just kind of be giving you guys introduction and just easy way to figure it out. We're also going to be recording this on our YouTube channel as well, so if you want to refer it back later in the night or tomorrow, um, feel free to do that. And let me hand it over.
Thank you so much, Trey. You pin this. All right, everyone hear me good? Maybe a little closer. Ugh. Sorry, it's my first time actually handling one with microphones. I work with them all the time, but I actually never end up using one myself. All right, so welcome to Intro to Git, everyone. As Trey introduced, my name is Jacob Ellerbrock. I am on the tech team and logistics team here at RHX. Some other credentials I have. Actually, I can go to the next slide. Yeah, I am also one of the HackKit, this is blinding me, HackKit developers. This means that I help develop the portal that the RHX uses, this check-in stuff, the what you scan your QR code with. I helped create part of that. We are part of a team that actually uses Git and GitHub. This information I'm teaching you all right now. Some other stuff, I'm ACM UTSA's technical officer, so I've been managing all the tech stuff there. But I have been using Git for a very, very long time. It is one of the tools that I love the most because it's so helpful in the normal industry standard. I've also had several internships with big companies. I'm actually working with HEB right now. We are using Git there. Literally everyone uses Git, so this is very important information for y'all to learn. All right, so what I want to first break down is, I'm sure y'all have heard of GitHub, right? Everyone says have a GitHub account to push to your repo, have a good commit log, all that stuff. Does anyone here have a GitHub account? All right, good. So most of y'all have a GitHub account. That's a really good start. You want to send your GitHub account to any employers that you have because they look at this stuff. They look at your projects. When you submit for Rowdy Hacks, you're going to submit to us your GitHub because it allows us to look at your project. The difference, though, is between Git and GitHub is Git is separately on your local machine. It is a software. It is what version controls your actual code base on your computer. GitHub is actually a website. It is not on your computer. It is completely on the web. It is like, think about like a social media where you will post stuff and then other people can see it. That is what GitHub is. And then on side topic of that, there are other websites like GitHub, like GitLab, Bitbucket, but all of them use Git to version control and then push to the repository. So remember the separation that Git is on your local machine and GitHub is on the cloud. All right, so as I mentioned before, Git is specifically on your machine, version control for your personal computer. When I say version control, that means that it manages essentially versions or snapshots of your code. If you write something in the beginning and then you change something later, you can jump back between the two with Git. If you are following along, want to do some commands while we do this, there's a link to download Git. You can also just search probably Git on Google and find the download. You don't have to follow along. I'm just telling you some commands. I highly recommend writing these commands down or like on your phone notes or whatever, because these are very, very common commands that you use. These commands I'm going to show you, I use literally daily, literally all of them. They're extremely helpful. All right, and then GitHub, as I mentioned, is for online repositories. Think of it like, again, like a cloud social media, Google Drive. You basically push everything to your to the website on your repository. Here's a link to GitHub. If you haven't created an account, I want to force y'all to actually create an account because this is really helpful for your journey. I have never talked to anybody who is in a high up position that does not have a GitHub, or at least something on their GitHub. All right, so Git basics. So creating your first repository. Let's say the project that you're working on right now for RowdyHacks, you are working with a team, but you need some way to share it. You don't want to do like Microsoft Word where you all sign into one document, and then you're stepping on each other's toes trying to code one file. What if you're all working on the same file, and you're trying to overwrite each other's code? It gets very, very messy whenever you try to work in a similar or on the same repository. So what I first want to bring up is think of your Git as like a tree. You can see here that there are nodes. Every node on a tree is called a commit. These are essentially snapshots of your code. For example, if you write 3 files, then you want to commit it. That will then save a snapshot of your 3 files. You can then create more commits. So for here, C1, C0, C1, and C2. These are 3 different snapshots of your code. Say I change a couple files or add a couple files to the project, and then I commit that new one. This creates a new node of changes. So every single one of these is like updating your branch. Think of it like when you're typing Microsoft Word, you hit save, right, to basically make sure that all your changes are there. And then and I believe in Microsoft Word you can go back and save histories. Think of it like that. You go back in your previous saves to what you end up typing in the past. You see right here that the nodes actually split off. So their C3 and C4 are both split off from C2. This is what's called a branch. If any of y'all have heard of Git branches before or looked at GitHub, there's that little tab bar with the branches. This is how you essentially create more different snapshots, but like naming them or putting them in a separate category. For example, with branches, when you use Git branches, you usually end up doing some sort of feature. I like using the example of TikTok, for example. Whenever people create the TikTok app, what are features that people think of? Like what's a feature of TikTok? Filters? Sounds. No one else uses TikTok? Am I the only one? All right, so I'm thinking like basic features like filters, sounds, maybe likes, liking a post, sharing a post. These are all different features. And you don't want to essentially have a straight line of all these commits saying, first I'm going to work on likes, then I'm going to work on features. You usually assign different people to those different tasks, right? For example, when you're writing a research paper, you usually break up the task. Say you're going to write the introduction, you're going to write the first argument, you're going to write the second argument, and then you'll all come together with what you have to basically put it all together in one big paper. You have to use branches for. You branch off to different features. You're going to code the like feature. You're going to code the filter feature. You branch off to create your own node, your own snapshot. Because again, if you're trying to work on the same stuff, you're like overstepping on each other. What if you're editing the same files? Then you are going to run into issues. This is what branching is, and you can see right here that nodes. You can have a different amount of nodes in every branch. For example, if I'm working on the like feature for TikTok, what if I want to have 10 commits? I save my files 10 times, whereas someone else who's working on the save feature only uses 2 commits. It's completely up to them, but the branches are to separate your code from one another, so you can work on your part individually, so no one else is like interfering with you. And then what you do is then you bring them back like this. They all converge to C6. They merge back together. Every time branches converge, it's called a merge. I don't know if any of y'all have heard about a merge before, or the scary thing of merge conflicts. But whenever you all come back to your project and you say, my like feature is done, I want to put it back with what the main branch is, then you all merge into it. All right, so I've been saying files or commits a whole lot. I was saying like it's a snapshot of your project. Here's an example of what is inside a Git commit. It's literally just files. It is or file instances or changes in files. So for example, you can see here that there are a project, or it's a Git repository due to the .git files that are in here. This is a Godot project I've been working on. Files that are ready to get committed, they need to be tracked by Git. So you need to tell Git, hey, I want you to track this file and this file and this file. Maybe this folder, maybe this other folder. These files then get tracked by Git, and then you can commit them to basically save a snapshot of them, and then you can go back to them if you like overwrite something. I will show you how to do that later. But let's say I want to stage scenes, scripts, and this icon.svg. I will then add these to what's called the staging area, where Git constantly tracks them. And if there's ever changes in them, then I will want to commit them so they get saved. So here are some commands for the Git that I've been talking about. So to add files to a staging area, you will run git add, and then the file. You can do, for example, git add icon.svg. This will add the icon to be tracked. If I ever change that icon, then I will run git commit to create a new instance or a snapshot of that, or a node of the changed files. If you ever accidentally create or add a file that you don't want, you can run this git reset command. It's kind of complicated, but it essentially means reset to what you had before you actually ended up doing anything. Head is essentially just the very beginning of your node. So you can get reset head, the file that you want to reset, or just redo everything with the dot. Dot means current directory or everything inside your current file. And then git commit -m, I'm saying commit a lot. To essentially finally create one of those nodes, you run this command, git commit. And this -m commit message, it is very, very important to describe what you created, because I don't want to receive the save feature from TikTok. Somebody created the save feature, but then they left no message or said, this is the filter feature. No, it's not. It's the save feature. I don't want to read through the code to determine, is this the save feature or the filter feature, whatever they said. These are the commit messages are for, and these will show up whenever you are logging through everything. So it is very important to add commit messages. For example, whenever I add this icon at SVG, I do git commit -m for add a message, added icon. I believe whenever you do git commit, it actually forces you to put a message by opening a text editor. So very imperative that you create or have a good git message, because it's important for other people to understand what you have added. Because everyone will be looking at what nodes you create and what is inside of them. Or they don't want to look inside of them. They just want to see the git commit message and understand what you're doing. And then also it's very helpful for you as well, because what if you come back to a project a week later and you're trying to understand, what did I add? What did I change? What is under this branch? You use these git message or commit messages to help understand what is in them. All right, here's some other commands. I was talking about logging earlier, where you can see like how many commits you've done, what exactly is in each of those commits, what those messages are. You do git log to see what you have done, what those messages are, how many commits you have. You will see there's also an ID which you can then use later. Git status actually tells you if you have files that are ready to be committed. Whenever you add files, they get added to the staging area, like I mentioned before. Git status will track if there's been any changes, if they need to be committed or not. And then this is to hard reset to when it commits. So I was saying before with Word, you want to maybe roll back to another save, to a previous save, because you changed something and you don't like it. So instead of just trying to remember what you saved, you just roll back to that previous save. This git reset, hard reset, will bring you back to your whatever commit you specify. Whenever you do git log, there will be a very large string of numbers or letters that dictate or basically identify which commit you have. And then, again, using those messages, knowing which one you want to go back to, you then git reset, a hard reset to whatever commit ID you want. Another way to do it is with git revert. And then git restore will basically bring back any changes that you have made previously. So for example, if I end up editing this file, this project.godot, and I want to go back to what it was before I started changing, I would just do git restore and then project.godot. Is anyone lost so far? Anyone confused? All right, good. Okay, so we were talking about nodes a lot, basically how to create all these commits and stuff, all these different nodes through our tree, but also about branches. Branches are very, very common in the classic workflow. All companies use them to differentiate what is being worked on, because again, I don't want to be working with the same files that someone else is working on because we work on different things. There's no really reason to basically try and interfere with each other. Because if we end up committing into each other, then I don't want I want my tree or my node list to be separate from whatever someone else is doing. So usually features have their own commits. I mentioned before that use the example of TikTok again, like will be its own feature, its own branch. Filters or sounds will all be their own branches. Another way to do it is just every developer has their own branch. For example, my branch would just be named like Jacob Dev. Someone else's branch would be whatever their name is, or however they want to identify themselves as. But usually, most companies do features. That's what I recommend doing because again, it makes everything more readable. For example, if you want to look at the code that has been using to create TikTok likes, you would want to go into the like branch because it's more it's easily readable, like what code or where all the different code that is being written is. And then again, branches are essentially an easy way to keep partitions, so people aren't like rewriting over each other. It's very easy to create your own log of stuff. It's also helpful if you want to like jump around with different topics. For example, if I'm working on both the likes and the share feature, I would want to create two different branches so I am not overwriting. For example, I write one part of the like feature and then I write a part of the save feature. I don't want those two to be in the same thing, because what if I end up not liking a part of the like feature and then I want to revert it? Then I have to go through or run the risk of possibly going back through the share feature. It's just an easy way to separate which part you're working on. All right, so commands to create the branches. Git checkout -b, the branch name. So this essentially, checkout is essentially, it means to preview whatever code the branch has. The -b flag tells Git to, if the branch doesn't exist, to create it. So you can see down here, git check out the branch name. If the branch exists, it will then switch to that branch. For example, if I'm on the like branch, I would do git check out save, or whatever the branch name is, to jump to that save branch and then look at that code there. You do just git branch like this to see all your branches that are in your project. For example, if I forgot like how many branches there or what branches there are, what the names are, I can just do git branch to see all the branch names. And then here's an example. So get checkout -b and then the branch name a feature. You can't have spaces in branch names, so it's common to denote spaces as the hyphen. And then to delete a branch, for example, say if you're finished with the like feature and you successfully don't want it anymore, you can do git branch -d to delete the branch. All right, so merges. So merges are the scariest part of any developer. Essentially, it's the teamwork aspect of coding. I have to make sure my code works with your code, and there's always possibilities for issues to happen, because I'm sure we've all had that group project where you do all the work and somebody doesn't, or they don't do it right, and then you have like clashing topics, and it gets really annoying. So merges are scary. It's putting your code together with someone else and making sure it all works. I don't like socializing, so that's part why I don't like it that much. There may be issues where you and a fellow developer have changed the same file. This can create what's called a merge conflict. Essentially, you don't know whose changes do you take. Do you take mine because it has to do the like feature, or you take your fellow developers who's coding the save feature? What if I did the same file? You're not sure. You essentially just have to pick and choose which one you want, or I want this line from mine, I want this line from yours. It gets very complicated, so I highly recommend using an IDE or a developer environment like VS Code, and JetBrains IDEs to go through merge conflicts. Their UI makes it very helpful because it can easily like swipe in like what changes they have to potentially bring together. So yeah, I personally recommend going through merge conflicts with GUI. All right, merge commands. So how to actually bring your code together is just git merge the branch. So whatever branch that you are currently on, it will end up taking that, whatever branch you specify will merge that branch into yours. So if I am on the like branch and I want to merge in the code from the save feature, I will do git merge save, and then it will bring all the code in from the save feature into my branch, the like feature. And if you want a visualization, I think I have the branch, yeah, the tree right here. So I'm on this is main right now, and or the branch main, and then I do git merge add feature to move all this code into main, and this creates a whole new node, whole new snapshot. Okay, so I've talked a lot about Git, how to version control your own projects. This is very helpful to essentially create these logs, but you want to share them. You want to be able to send your code to your peers, to your other possibly teammates or employees to make sure that they get the code that you're writing. Or if you want to showcase your code to the world, if you made a cool project, I highly recommend putting whatever you code or whatever you make for RHX this year on your GitHub, because again, employers look at the stuff. They look at what projects you have. They look at your pen projects, the projects that you have worked on the most, and they go, hey, what is this? You can easily talk about your project whenever you can easily pull up, this is my GitHub, this is my code repository, my actual project, and this is what I worked on. You can actually show them like what features you've added and stuff. So highly recommend, if you don't have a GitHub profile already, to create one. It's very easy. So again, GitHub is all online. It is a website. Don't confuse it with Git. If you want to, so many people have repositories already online. For example, if you want to copy, if you ever want to work on like a portal like we have with HackKit, or the portal that you're using for RHX, it is what's called open source, or available to anyone to basically take down or copy. There are projects that aren't open source, are closed source. For example, a lot of the video games are closed source. Big companies like Microsoft have their code closed source, because you can't just find the code in Microsoft anywhere. But people that have their repositories or their projects on GitHub or open source, you can clone their repository onto your local machine. For example, if you want to download the code to the portal that you're using for the scanners, you can by just going to our GitHub repository and then searching up HackKit, and then you will clone it. If you want to make a variation of another repository, for example, if you like our portal so much, but you want like some modifications, like change the color scheme or add another feature, but you want to create your own repository of it to make it on your own profile, you can fork the repository or create a like brand new subsection, not really subsection, but a new like iteration of the repository. And then a formal way to go about merging is called pull requests. So I mentioned before how when you merge one person's code to another, it creates those merge conflicts. But usually again, Git is on your local machine, so you only really merging branches with yourself. So I think that makes it kind of easy to differentiate which code should be where, because again, you wrote it yourself. But to share it with your peers, you have to go through GitHub, right? So to do pull requests, GitHub has a very formal way of going through with that, where you can create a title, a description, and then you gives a list of all the commands or commits, the nodes that you have created, and then it allows people to see what you've coded. It allows people to review your code. Say we're not all perfect. You may write not so great code like I have in the past. You want people to review your code and say this line doesn't make sense. You can do that in a pull request. It allows people to review your code, and then when they approve it, then it can get successfully merged or merge into whatever you're trying to go to. So to get to GitHub, or to be able to use GitHub with your, say, RHX project, you need to some way connect your Git to GitHub. You want to be able to upload your code from your local Git repository into GitHub. You can do this by setting a remote pipeline. This essentially is an easy way for you to push your code from your local machine into a GitHub repository. So whenever you create a repository on GitHub, you get a special URL. You can then use that URL to then create a remote pipeline. I'll show you in a second how to do that. essentially think of it as you are taking this entire tree that you've built over however many commits you do, and just snapshotting the entire tree and then pushing it to GitHub. You're not really pushing nodes, you're not really pushing branches, you just push everything that you've added. Or in certain cases, you can pick and choose by with the staging area, adding certain files to what you want to push. But this essentially creates a snapshot of your work tree of all the nodes and branches and merges that you do into GitHub. If there are any changes made online that you don't have, for example, say you and a couple of people are pushing to the same repository, and someone makes an update, you have to get those changes somehow or pull those changes down to your local branch. This essentially goes the other way, where instead of moving your local machine code to GitHub or the cloud, it gets the cloud code that's already on there into your local machine. So there's a two-way path with that. And you need to make sure that you stay on top of both of those, because again, it make sure you stay updated with all the code. Because if I'm working on the like feature, but somebody else has been working on the save feature, but also changed like the UI, maybe added some helper functions that help with counting and stuff, I want to be able to use those functions. I need to pull the code that they have to be able to use those functions. Unless I want to code it myself, which then that's redundant, and there's really no need to code something that someone else has already coded. So to create this remote pipeline, or way to get from or to connect your local Git machine to a online repository, you're going to do git remote add, the name, and then the URL. So all these remote pipelines have a name. The most common name is origin. I've honestly never seen another name other than origin. But for example, you can do git remote add origin and then the URL that you're given. Whenever you create a repository, it'll be like really big on the repository what the link is. I mentioned cloning another repository. You can just do git clone and the URL. I believe that is also given whenever you look at a repository. And then to essentially push any changes, push your work tree, remember that entire snapshot of your work tree, you can do just git push. This will push any commits that you have, any commits that you have like edited or changed or merged in, branches you've made. It will, again, take that entire snapshot and just move it to GitHub. You will have to do some like authentication whenever you first do a GitHub push, because GitHub needs to make sure that like you are who you say you are, because anyone can use in your machine. So you will need to like log in with some token. It's a really easy process, and there are documents on how to do that. Git fetch all. This doesn't get the code. It essentially gets like the framework or the structure. If there's any branches that are new, git fetch all will make Git aware of what is on the GitHub repository or the online repository. So for example, if a new save feature branch has been created, I got to use git fetch all to make sure that Git knows that branch exists. Because without not knowing what the branch is, you can't check it out. So to get a branch from online, you can do git checkout -t, the name of your remote access pipeline, which I'll just name origin, and then / whatever branch name you're getting. You have to use this -t, or else it will not really put it into the tree. It will only like create it like separately, or it's called detached, which I've never found a reason to use it detached unless you're literally only looking at the code and then just throwing it away. You can do git branch -r to view what branches are on the remote side or online. Because remember, you have to make sure that Git is aware of these changes or these new branches with git fetch all before you can actually run git branch -r, because it won't know that they exist. So the way to pull or to get code from someone else on the GitHub repository is you git fetch all, and then you can look at the branch with git branch -r, and then the git checkout. I think another command I forgot is git pull, which will essentially just update all of your code. If you're already on a branch, so say that you're already on a branch that's a part of the origin, you can run git pull. It's just like push, but instead it's saying pull to get those changes or any updates to it. And I'm sure there's already, that is essentially the basics of Git. If you have any questions, we have a large mentor list panel of people that are available to help. I know Git can be very confusing at times. Essentially, I still get confused with it a lot, but it just takes time and practice. Being able to visualize or drawing out like the nodes that you create or the branches you create is very helpful to determine what code is where. Yes. I will be posting these slides probably in the announcements channel after a little bit whenever I finish wrapping up this. But yeah, all these commands will be posted in the GitHub. This stream is also going to be recorded on our YouTube, ACM UTSA. Yeah, you'll be able to watch over this stream again if you miss any information or just want a reminder of how it works. If you don't want to watch the stream, there's a lot of Git documentation out there. There's a lot of people that have worked on issues with Git that are able to help solve anything that you're having. And if not, you can always just reach out to me to my Discord or my email or any of the mentors that we have. They all should know Git pretty well and are able to help you. I highly recommend that you use Git or try to figure out how to use Git on your current project that you're working on at this hackathon because as long as you upload everything, it makes it very easy for the judges to go through your code, go through your project. And then you also want to keep that project on your GitHub profile because, again, employers love to see projects. They love to see a full GitHub profile that has a bunch of your projects because, again, these are talking points for interviews that you have. GitHub is essentially the software that everyone uses to view these projects. Again, thank you for coming to the Git workshop. And if you have any questions, feel free to reach out and let me know. Thank you.
Thank you so much, Jacob. Okay, so we're going to be doing